So welcome to our CCNP class again. I really appreciate everybody moving to Wednesday for us during the month of April. It's been the ASC meetings. If you haven't had a chance to attend them, they've been really good. Yesterday we had a great meeting where we went through and looked at the offerings from NDG on their portal project and the cloud project we've been part of. And we actually, next week, the meeting, I'm going to spend almost 45 minutes going through and showing Cisco modeling labs. So it's going to be a good way to look at Cisco modeling labs. And then we've also got a gentleman from Splunk coming in to make an announcement from Splunk. And someone's coming in to actually show how to do some custom pod designs in NDG's NetLab. So pretty cool set of stuff coming up next week. If you can't attend, obviously it's 4 to 6 on a Tuesday afternoon. So it's a long time, but I do post each one of them on my YouTube channel. So feel free to go through and watch them. I have not posted yesterday's yet. I'll post it tomorrow. I technically took today off, but I'm doing my class. I said I'd do my class. So I want to open up questions. Anybody got any questions about what's going on, where we're at, what's happening? I want to show you a couple things here. Are many of you going to take the next class?
I am.
All right. This book is the next book in our series, and it's 800 pages, so it's long. But it's the next book. It's NARSI book. So I just ordered it and got it in. So you may want to go ahead and order you a copy. Unfortunately, we don't have inside of our current students, inside of the Safari Online, we don't have the book, this book. But I think there is a video course on ENARSI, but just kind of to get ready for the next class, if you're taking it, I would go and order the book. And because originally they told me that it was going to take me about 2 or 3 weeks to get the book in. So don't wait to right when class starts to try to order it. Otherwise you'll be behind getting your book in and getting your reading started. The other thing I do want to do again is remind you that there's a lot of material in the book we're currently using that's not necessarily on the exam. And I'll be up front with you. I used I'm using Cisco's online learning to go through and prepare for the not the ENARSI, but the CCNP ENCORE. Actually, wait a minute. This book, nice command reference. So there's a video course, but not the book itself. So you'll want to probably buy yourself a book. But one of the things I want to note is that content does not even really go over at all the old school method of doing IPSec tunnels. So if you look in our labs, we have for us in the lab library a lab which is a very, very good lab, but it's called Creating IPVSec Tunnels, right here, Implementing IPVSec Tunnels. And inside of this lab, you'll notice that we use the old method of creating, well, it's called the old method. It really is becoming a legacy method for IPSec tunnels. But that is, you'll go down here and see we basically create an ISACAMP policy. We create a IPSec transform set. So by the way, remember IKE equals ISACAMP. So anywhere they say IKE properties, they're really talking about creating ISACAMP policies. So because there's an ISACAMP policy. But in the old method, we'd create an ISACAMP policy. We would create a transform set for IPSec. Then we would create what's called a crypto ACL. And so this access control list would be what determines what gets encrypted, and in other words, what gets shoved into the IPSec tunnel and what does not get shoved into the IPSec tunnel. The problem with this is it would not support anything but unicast. You could not put multicast through it. You could not put broadcast through these. And so there was a real big limitation using IPSec in the old method. So you could do GRE and put GRE tunnels inside of it, but what we've actually come up with and what they've developed is a new method using virtual tunnel interfaces. So that's what I want to show you today. I want to bring some things over here. Here's my notes I've been keeping up with. But looking at the old school, okay, so basically looking here, we're going to look at a couple things, but looking at IPSec. Anytime you do IPSec, whether you're doing it the old method with crypto ACLs or the new method with virtual tunnel interfaces, you still have to agree upon an ISACAMP policy. That's the IPSec has two phases. One phase is IKE phase. Really, IKE has two phases: IKE phase 1, IKE phase 2. But I kind of lump them into, you've got an IKE phase and you got an IPSec transform set phase. So you've got to agree upon this ISACAMP policy, and that connection has to be made. So you have to create what's called an IKE SA. Okay, so let me bring up a notepad here. You got to create what is known as an IKE. Well, it's actually, I call it ISACAMP SA, which is Security Association. In fact, you're going to see the command is show crypto ISACAMP SA to see the SA. And then you've got to create an IPSec security, let me spell this out, Security Association. If these two are not able to be created, you will never create that IPSec tunnel and won't be able to send anything through it. So it's important to know that when we're creating IPSec, tunnels, we're going to have to create an IKE policy or ISACAMP policy, and then we're going to have to create an IPSec policy, and we're going to have to all agree upon these rules. And then if that happens, instead of in the old method, we used crypto ACLs. Okay, so in the old, what we're calling more of a legacy method, used what's called a crypto ACL to determine what got this. Basically, that ACL determined what was encrypted. Okay, and one of the things I teach my students at the beginning of CCNA is that ACLs are used for everything. And think about it, they really are. They're used for security. They're used for access to your VTI lines. They're used for matching. We've already used them earlier in the class to match information for route policies. Now we're doing learning that in the old days that with legacy crypto ACLs, they were used to determine what would get encrypted. Well, with our VTI, our virtual tunnel interfaces, the difference now is instead of using ACLs, we're just using IP routing to determine what will be encrypted and what will not be encrypted. Does that make sense? I must have made Matthew mad.
Yeah, that makes sense.
And May got dropped off because he had a phone call. All right. The other thing I want you to think about is there's two different modes for IPSec tunnels. One is transport mode, and one is tunnel mode. And the main way to delineate these two is where the endpoints are. In transport mode, only the data portion gets encrypted. So that is for when, let's say you've got a user who's at a hotel, you don't control the IP addresses for where that user is coming from, so you can't rewrite that header. All right, Andrew, yes. a little bit quieter. Okay. All right, you can't rewrite that header completely. You can put a wrapper around the data, but you don't know what IP address they're coming from. So transport mode is really for what is another name for transport mode is remote access VPNs. Tunnel mode is for when you control both sides. You know exactly what the IP addresses are on both sides. So you put a new complete header onto the IPSec information, and you can wrap the entire thing and it gets put inside of it. So that's our two main types. And then we do have what's called Cisco DMVPN or dynamic multi-point VPNs. This is where you can basically create them over a public WAN, and it's with DMVPN. One of the main points is that branches can actually communicate directly to one another. So instead of having to have a central hub and spoke set up, you do have a hub and spoke setup, but then the spokes can still talk to one another. So if you have, let's say, voice over IP and two branch offices call each other, they can go between those two more easily. And then last but not least, I've got this new Cisco Ios Flex Vpn, and it's got the ability to do site-to-site and remote access VPNs and redundancy and all kinds of things. We don't do a whole lot in this class with Flex VPNs because we're more focused on, as far as we're looking at configuration of VTIs, but it is another method that we can use. Now, let's look at VTIs. All right, with virtual tunnel interfaces, we've already made tunnel interfaces last week. We did that as part of our class. I showed you how to make a GRE tunnel, how to set your endpoints. Well, we do the exact same thing for virtual tunnel IPSec over virtual tunnel interfaces. You'll notice our mode is different. We're doing tunnel mode IPSec IPv4, and we're setting a transform set, an IPSec transform set, to be used across that tunnel. This is one reason why I was kind of like, well, this is not very different from legacy. They tried to act like it was something different than legacy, but it's not. I mean, honestly, we're setting up an ISACAMP policy. We set our ISACAMP pre-shared key. We create our transform set. We create the IPSec profile, create the tunnel, and then apply it to it. The only thing we're not doing is making a crypto ACL. Instead of doing that, we're using this to apply it, and then just saying, using our actual routing is how we will determine what gets put into the tunnel and what doesn't. So we're going to end up saying this traffic goes across the tunnel, and that will be done with the routing protocol instead of using a crypto ACL that will make that decision for us. So honestly, it's very similar to what we used to do in the legacy world, or what they call legacy, but it's not really all that big of a difference. So let's go now. Let me find my, there it is. Trying to find my, I might have to make this a different size here because this wants to move over to my other side. I just bought a new monitor at home, so I'm kind of still playing with figuring out the best ways to do things here. All right, so we've got our content over here. I've already dropped in all of the pre-configs that I've given you. Let's see if we can make this work. So it's ping 10, 10, 5, 10. It helps if you don't put 2 dots. All right, so we have pingage. So let's do actual size. So we got pingage to 10, 10, 5, 10. All right, from PC1. And then on PC1, let's ping 10, 10, 16.1. All right, we're good. And then last but not least, let's ping our 209.165.200.225. And we have full pingage. So everything's good there. Look at our routing table, do show IP route. And we've got, oh, they want us to do just OSPF. Okay, do show IP route OSPF. I'm just going to do the whole thing. I'm not going to. So we got 10, 10, 10, 10, 2, 10, 3. All that's good. Let's go look at R3. Do show IP route OSPF. We're good there. Got a bunch. Okay, so we got 5, 16, 17, 18, 19, all the way down to 23. Okay, so we're going to start the configuration. I'm going to turn off my video so it's not in the way of the item here. So we're going to start, and we're going to say, here's one of the things, a big point here. IPSec VPNs can only broadcast unicast traffic across a VPN tunnel. Therefore, the routing protocol traffic will not propagate. You could use GREs, okay, and GRE would allow you to do that. But if you use a VTI tunnel, VTI tunnels can actually propagate that information. So static VPI tunnels can be used for site-to-site connectivity. Dynamic VTI tunnels are when you're doing remote access. So we're going to set up a VTI tunnel, and we're going to create the tunnel interface and give it the tunnel mode of IPSec. We're going to set our transform sets, both IKE and IPSec, and then we're going to apply them. So first things first, we're going to generate a policy, an ISACAMP policy on both R1 and R3, and those have to match. There has to be at least one matching one. So let's try something here. Let's do show ISACamp. Actually, let me drop all the way out so we don't have to do show crypto ISACamp policy. And you'll see there is a default policy that is already in place. There's a set of default policies. So it will try to use AES, it'll try to use SHA as a hash algorithm, it'll try to use signatures, and it goes all the way down. There's several of these already built in with built-in numbers that show how they will try to be used. We're going to put a new one on here. So we're going to do config T, and we're going to set a crypto ISACamp policy. Oops, I can spell it right. Policy 10. And we're going to say that this is going to use encryption of AES 256. We're going to set it to use a hash of SHA 256. Helps when you type it right. We're going to do authentication of pre-share. Okay. Group. Now this group is your Diffie-Hellman group. So the higher the number, the more secure it is, but also the more processor use it takes. And then lifetime is your transform sets lifetime in seconds. So we'll do 3,600. And what that means is at the end of this time, the Security Association will have to be redone by the device. So now let's go over to R3, and we have to create the exact same thing again. So otherwise, we would not have matching ISACamp policies. So it's a little bit of boringness here, but we got to do it just to make sure we get it. 256 hash SHA 256 authentication pre-share group 14. Okay, and that we got to set lifetime 3,600. All right, now you'll notice we've got the correct ISACamp policy. So now we got to set our pre-shared key that will be shared with the opposite side. Now, if we look at our topology, we can see that we're sharing this. We're saying that for the host on R1, the host at 64.101.2, which will be our tunnel endpoint right here on R3, we're going to use a key of Cisco 123, and R3 is saying for the host at the endpoint 64.100.0.2, we're going to use the key of Cisco 123. So we'll drop over here and we'll do it first on R1. So crypto, and notice it is outside of the policy. We have to go into global config to do this. Cisco 123 address 64.100.1.2. All right, we go to R3 and we'll do crypto. Oh, that's R2, fixing to mess up. I wonder why that was on the crypto ISACamp key. Cisco 123 address 64.100.0.2. Okay, so now let's go ahead and do it while we're over here. Let's create our IPSec transform set. So crypto IPSec transform set VTI Vpn. By the way, that's just the name of it. ESP AES 256 ESP SHA 256 HMAC mode tunnel. All right, now we'll go over to R1. We got to create the exact same matching set transform set. Now if I do a question mark, you'll see it's just word. So the VTI VPN is just the name that you're going to use for this particular crypto IPSec transform set. All right, so that's done. Mode tunnel though. can't do that. Mode, wow. Cap locks is on. All right, so mode is tunnel. Now on R1, we're going to apply that particular transform set we just met or just created to our IPSec profile. So we'll go back up one. Crypto IPSec profile. IPSec profile. VTI profile. And then we're going to do set the transform set to what we built, so VTI-VPN. Okay. Pop over to R3, do the same thing. So crypto IPSec profile, VTI profile. And we're going to set our transform set to that VTI. Now, at this point, we have done the following. We have, well, let me actually pull this back up. So we've actually, at this point, created our ISCAMP policy and our key. We've created our transform set. We've created our IPSec profile. So now it's time to create the tunnel and apply the profile to the tunnel. So that's our next item we're going to do. Okay. So let's go to R1 and let's create us a tunnel. So interface tunnel 1. So int tunnel 1. All right. Now we're going to do bandwidth. We're going to set a bandwidth on it to 4,000. Oop, not 400, 4,000. IP address of this tunnel is 172.16.1.1 space 255.255.255.252. Control A, by the way, don't forget, lets you go all the way back to the beginning. So when you make a mistake like I just did, you can do it like that right there and save yourself a lot of time. Setting the MTU so we don't have to worry about problems with the headers. Tunnel source is going to be that 64.100.0. Tunnel source 100. Control E 2. And by the way, that's why that key was set on R3 to go to this 0.2. And then our tunnel destination is set to the IP address of R3. And that is how we know that we've got it going over to R3. And then tunnel mode, IPSec, IPv4. And last but not least, we got to put in our protection. We got to apply the IPSec parameters. IPSec profile, VTI -profile. All right. And so we're good to go. This side on R1 is done. We'll go over to R3 and do int tunnel 1. We'll do exact same thing on R3. We got a mirror. We're mirroring on R3. Bandwidth 4,000. IP add is 172.16.1.2. It's the opposite side of the /30 for this network. Okay. And then we're going to do our IP MTU of 1400. Tunnel source is 64.1.2. Tunnel destination. Okay. Tunnel mode would have to match. So tunnel mode is IPSec IPv4. And then we're going to do a tunnel protection. Protection, IPSec profile, VTI -profile. Now, the problem we've got is right now, you're still not going to be able to have any traffic go through this tunnel because we don't have any way to say what will be put into the tunnel. So we're going to start advertising these networks into OSPF. So we'll go in on R3, router OSPF 123. We're going to do, by the way, let me do a do show crypto ISACamp SA. Okay, you'll notice it's idle. There's an idle right here. It's waiting, but it's idle. Now let's do a IPSec SA. You'll notice no packets are being encrypted, no packets are being decrypted. So at this point, although we've got it set up, nothing's actually flowing through the tunnel. So now let's see if we can make some stuff flow through the tunnel. So network 172.16.1.0 0003 area 0. All right, and we'll exit out of here, and then we'll go over to R1. Let's do router OSPF 3 work 172.16.1.0 0. Okay, and exit. And now, okay, so we're going to verify our static VTIs here. So let's do a do show int tunnel 1. You'll see it's up, so tunnel is up. You'll notice if you look down here, it's going to tell you that the mode is transport IPSec. Okay, we got our source and destinations, so everything's good there. We've got our protection. There are tunnel protections via IPSec, and then same thing would be on R3. I'm not going to jump back over there and do it again. So now we're going to look at our crypto session. So let's do a do show crypto session. And you'll see that tunnel 1 is up, it's active. We've got an IC1 SA. Okay. And so now if I actually did a do show crypto ISACamp SA, it's active, it's still idle. Let's do a do show crypto IPSec SA. Notice now we've got traffic being encrypted. We got things being encrypted because we're now routing across this particular tunnel. Okay, so we've got routes now, and the reason we did that, we did the band. Notice we changed our bandwidth on it, and that's one of the reasons why traffic is now. We do a do show IP route OSPF. You'll notice now traffic's being put through the tunnel, and that's why we changed the bandwidth to make sure that it would go through this tunnel instead of through the gigabit interfaces. Before we had, you'll notice we had traffic going out gigabit 0.1, okay, on R1. But now on R1, everything's going through the tunnel. And vice versa, it'd be the same on R3. On R3, you've got things going through the tunnel instead of through. So we're going to R3 here and do a do show IP route OSPF. We got this information going through the tunnel. So if we do a do ping 10 actually, let's do this. Let's back up. I'm gonna go to Control Z. Let's do a ping 10 0 1. Just make sure that just the ping just works here. Okay, let's do a extended ping IP target IP address 10.0.0.1 no 10.0.1 repeat count bunch. Okay, now let's go back to R1 and let's do a do show crypto IPSec SA. Okay, 6,000 packets being decrypted. Now watch this. As we go through here, we'll keep doing it. It's going up 9,000. So our ping on R3 that's causing all of this is making, we can see it's being encrypted by looking at the SA. Okay. So we have a static VTI tunnel using all the setup that I discussed with you and showing that we are now sending information through that VTI tunnel. Like I said, from D1, you can do a trace. You exit, you can do a trace to 10.10.16.1, and you should see it go through the tunnel. And there it is going through the tunnel. And then again, I can show those encryption, the packets being decrypted, and I can show you that because show crypto IPSec SA. Oop. And all those packets are being encrypted. So we still got this going on. I hope I can break out of it. If not, we'll just let it keep pinging and keep looking at it. Notice the number keeps going up. So we got all that pingage going on. So this was a very good example of how a VTI tunnel with IPSec is set up. Are there any questions about this lab and about how this works?
I'm good.
Any questions on how this is better than our old method? One of the primary reasons it's better than our old method is because it supports multicast and it supports broadcast. That's one of the biggest reasons. But really, when you come down to it, if you look at it compared to our old method, it's not really that different. The only difference is instead of doing a crypto ACL, we use our routing protocol to set up what gets encrypted and what doesn't. If we had not changed the bandwidth on the tunnel, by the way, we would not have been able to, it would not have gone through the tunnel. It would have just gone through the, it would have gone through the typical OSPF because it had a better metric than what we had before. I probably shouldn't use 100 million, but it is what it is. Go big or go home, right? All right. That is, by the way, IPSec using site-to-site VPN using virtual tunnel interfaces. Let's go back over here. I got a lot of people in my CyberOps class doing labs. I don't really want to talk too much about these other methods, folks, because they're not covered that much on the actual exam. But if you wanted to, you could see you can run GRE through an IPSec tunnel. So it is possible to actually do it that way. So you create a IPSec VPN and put GRE inside of that particular. So you're using it. There's two different ways. You can GRE over IPSec with a crypto map, or you can do it with a tunnel profile. And this lab goes through that. Feel free to do it, but it is, it's not covered greatly inside of the exam. But you'll notice, look at how similar it is. It's just create your IceCamp policy, create your transform set. Okay, so and you're setting your key just like you would before. You're creating a transform set, IPSec transform set, set your crypto ACL, and then you combine those two together with a crypto map. So the difference is the crypto map is where you set your transform set, your match address for your ACL, and your peer. And then you apply the crypto map to an interface instead of to a VTI tunnel. So we're doing the exact same thing. We're just doing it in a little simpler method over here on the VTI tunnel. And again, the beauty of it is actually GRE with IPSec inside of it can support different types of transport, but the VTI tunnels are allowing us to use our modern networks the most. All righty. Any questions? Stop.
I'm good.
Okay. Nobody else got a question? Folks, that's all I planned on for today, was to going over the VTI tunnels and talking about that a little bit and talking about VPNs. If you have any questions about it, please let me know. We are about a month or so, a little bit over a month away from class end. So we still got a good amount of time left for class. But everybody's doing pretty good. I graded stuff yesterday, went through and did a bunch of grades. So just if you're not at the point where you're getting ready, I think most of you, Corey, I know you're almost finished.
I'm busting through the labs. I still gotta go back and do the exams.
Okay, I knew you had a bunch of labs done because I think I graded one up in 19 or 20 for you just yesterday, or
Yeah.
several of them up in there. So
Try and get those knocked out because those are time consuming.
they are, but I hope the pre-configs I gave you are helping, and if you find any mistakes in those pre-configs, definitely let me know.
No, they're extremely useful.
Yeah, I hadn't found any yet, but that doesn't mean there's not going to be some. So, okay, everybody. Well, that's all I have. I'm going to stop the recording.